Okay, so hopefully you just got done watching the previous video where I was looking at graphing calculator, and we wanted to know what is the slope of this parabola, and that parabola should actually go more like that. And I was arguing that the slope of y equals x squared is equal to 2x. And we're going to get there eventually. Okay, so we have this idea that here we've got y2, x2, y2. And here we've got x1, y1. And we say that our slope is going to be y2 minus y1 over x2 minus x1. Or it's going to be change in y over change in x. That's for a straight line. Now, for a curved line, what we're going to do is we're going to zoom in. So it looks almost straight. And so then I'm going to do the exact same thing. I'm going to choose 2 points that are really close to each other, and that's basically going to be almost a straight line. And if I zoom in further and further and further, and I get those points closer and closer together, as I zoom in further and get those points closer and closer together, I'm going to get closer and closer and closer to a straight line. And so then what Leibniz and Newton did that was controversial is they said, hey, let's zoom in infinitely far and get our points infinitely close together, and then we will get exactly what we're looking for. Okay, so what they said is the slope of f of x, we're going to call that, or they said the slope of f of x the slope of f of x is going to be called f prime of x, or the derivative of f of x. So f prime of x is the function They said f prime of x is the function that gives you the slope of a curved line, f of x. Okay? And the way that they defined it, f prime of x is going to be the limit as h approaches 0 of f of x plus h minus f of x over x plus h minus x. So what we're going to do is, here I've got a point, and that point is going to be, well, let's look at that point. That point right there is going to be x comma f of x. And this point up here is going to be x plus h, comma, f of x plus h. And if I do change in y, I do f of x plus h minus f of x all over x plus h minus x. So change in y divided by change in x is going to give me the slope. And as I get h closer and closer and closer to 0, my approximation of the slope is going to become more and more exact. Now, I can simplify this denominator. So I can write this as the limit as h goes to 0 of f of x plus h minus f of x all over h. Now, we're not allowed to divide by 0. So we have to remember that we can't divide by 0. So we're not going to get to h equaling 0. We're going to take the limit as h approaches 0. Okay, so we're going to use this in my next video. And there's just a few things that I want to say on notation. So you know that delta y, so that's a delta, that's a capital Greek D, y. That means change in y. When we go into calculus, we're going to say dy, and that's going to mean we're going to go from change in y to really, really tiny change in y, or infinitesimal change in y. And then delta x means that's going to go to dx. And so then we're going to say, so then here we've got m equals change in y over change in x. We're going to call that average slope. And then we're going to have f prime of x, which is the slope of a curved line, is going to be equal to the infinitesimal change in y divided by the infinitesimal change in x. Okay, that's what I'm going to say in this video. I'll be back with more information.